we have another example on the board. Again, you're supposed to look first at the power supply and the diodes, okay? Again, let me remind you that we are talking about the conventional current flow. So theoretically, my current is supposed to go from the positive terminal of my power supply to the negative, okay? So I'm going to go in this direction. My diodes. Anytime you are going to see two diodes, right, connecting like this, when the arrowheads are going to basically oppose each other, okay, because this is like an arrow, okay, they are opposing each other. It means that the circuit in this branch is going to be open. Because if theoretically this one is going to conduct, means it's going to pass the current, the another one is going to behave like an open circuit. So basically we have no current flowing in this branch. So it means that my ID, the current which goes through the diode branch, okay, is equal 0 amps. Okay, so current, which I'm going to say is called ID, in this branch is equal 0 amps. Next, we're supposed to find the current which goes through the resistor. Now, this resistor is connected in parallel with the voltage source. Okay, so it means that I have 15 volts across this resistor. So if I have 15 volts across the resistor, I can find a very easy current. IR is equal voltage across the resistor, right? But I can write that this is also voltage source over the resistance. Voltage source is equal 15 volts and resistance is equal 33 ohms. So voltage divided by resistance gave me 454.54 milliamps. And this is the solution to my problem.